Good afternoon, everyone. It's a pleasure to be in Israel. Shalom. And my goal today is to make sure that everybody walks out of here knowing something about the difference between CNG and LNG. If everyone can walk out and know the distinction about CNG and LNG, I will have achieved my goal. Anything else that you extract from the presentation will be a bonus. These are the topics that I'm going to talk about today, and rather than focusing on the workforce, I focused on CNG because it's a new industry, it's a new solution that exists in the marketplace, and everybody wants to know how it works, what benefits it can bring. So this is what I'll focus on. These are this is the outline of the presentation. Our alliance, the group of companies that work together to deliver this solution. Marine CNG, and then application of the CNG. The Cosel system, that's our proprietary technology. Safety, which is very important in the oil and gas industry. Marine CNG markets, indicative tariffs, CNG versus LNG in the region. And then we'll go to conclusion. And I need to do this in 30 minutes, so I either have to speak faster or skip some things, so we'll see what happens here. First of all, let me introduce you to our group of companies. CNG is our company. We are the technology developer. I got 10 minutes bonus here, so that's good. And then, so we have developed the technology, and we market the technology, and we develop the projects worldwide. Marubeni from Japan, everybody's familiar with Marubeni. It's a $50 billion company with assets and projects worldwide, and they have almost 5,600 employees. And then the third company is TK Corporation. The head office is in Vancouver, Canada. And they are in the shipping industry. They have more than 150 ships with LNG, LPG, shuttle operations, and they are known to be like one of the best operators in the world with an exceptional safety record. And the last company is Enbridge, and Enbridge is Canada's largest natural gas distribution company. They have more than 84,000 kilometers of pipelines. They have assets in Canada and in the States, and then worldwide, more than 1,500 miles of subsea pipelines in the Gulf of Mexico. So this is the group of companies. Marine CNG, this is where I'd like to have your undivided attention. It's in order to move large volume of gas, you have two choices. You freeze it or squeeze it. So what does this mean? LNG is you freeze it. You take the natural gas, you reduce the temperature to minus 162 degrees C, and at that temperature, every 600 units become one. So it's very dense, and it becomes liquid at that temperature. Versus CNG, it's you apply pressure at ambient temperature, and the pressure that we have in our ships, it's 4,000 pounds per square inch, or 275 bars. And at that pressure, every 300 units become one. So just remember that LNG is twice as dense as CNG. So this is a very important feature. You freeze it or squeeze it in order to have an efficient transportation of large volume of gas. So you have an FPSO that the gas comes from the offshore well, and the gas is cleaned and dehydrated, as Jeff mentioned this morning in his presentation, and it goes to a buoy where there's a loading system, the submerged turret loading for deep water. A CNG ship that is empty with gas approaches the buoy, and it connects to the buoy, And you can see that this ship here is already being filled with the CNG. This is the turret loading system. All these components, by the way, are produced by companies around the world. So these are all proven components. Nothing is leading edge. It's leading edge, but it's available. And the full ship departs to the destination while the empty ship continues to fill. At destination, destinations normally is a power plant by shore or a petrochemical facility. There is a ship already there docked, delivering natural gas, and it's almost getting to empty. And another ship arrives, connects with this loading arm. Again, these components are made by manufacturers around the world. And this ship is almost empty. The ship connects in parallel. And then the empty ship departs and continue with the cycle. The size of the ship and the number of the ships in a fleet, it depends on the volume and the distance. We try to optimize the number of ships and in order to reduce the lowest tariff, the lowest transportation tariff. So this ship continues to deliver, and the cycle repeats itself. Normally, we have one ship arriving at the destination every day or day and a half. These can be also designed with the port authorities, and the delivery could be through a jetty at a port here at the location. It could also be through a buoy. So it's very flexible arrangement, a very flexible solution. There's no need for storage. The ship is the transporter and is the storage too. So most of the investment in the CNG projects happens to be into the ships. And you can notice that this power plant used to be operating on liquid fuel. So the liquid fuel, when you have combined cycle gas turbines, could be used as a backup, and we work with the utilities to determine what degree of reliability, what redundancy of having two ships at the location at the same time. Okay, so you have a picture now of shuttle operation, how it works. And let me just very quickly go over what's the difference between LNG and CNG. In LNG, you get the supply of gas, and normally it comes through a pipeline, but it's clean and treated natural gas, and it goes through, this is the treatment facility, and then you liquefy the gas. It goes into very large tanks that holds quite a bit of LNG, and then comes in a very large LNG ship. It takes huge volume of gas, sometimes maybe 20, 30, 40 times what a CNG ship takes. And then it departs to go to a destination. It empties its load into another tank, and these tanks could last, 20 days, 30 days of the needs of a power facility. Depending on the demand from the power facility, when gas is needed, it goes through a regasification facility, and that's basically, it vaporizes the LNG into gas, and then there's a compressor that brings the pressure of the gas to the pipeline pressure. So if the pipeline is delivering gas at 600 psi, at 70 bars or something like that, this compressor will take the gas to this pressure. So this is LNG, and it uses quite a bit of energy. However, the shipping, because it's a very large ship, and also because the liquid natural gas is dense, it has a global reach. So we say that LNG has global reach, CNG has regional reach. And the economic distance of CNG is about 2,500 kilometers. So mostly you can reach from Israel most locations in the Mediterranean. In CNG, it's really simple. If you're getting the same gas through a pipeline, you have a dehydration and then compression, and you put it on the ship, and the gas always stays as a gas. It does not change form. It gets to destination, as we have seen in the animation, and it delivers the gas to the power plant. There are many applications for CNG. It's used, like for example, I wanted to mention here that there are 16 million vehicles around the world that run on CNG. I got a question by one of the reporters this morning, just before the break, mentioning concerns about the pressure, And 4,000 psi is a high pressure, but I was mentioning that some professional divers in the U.S. They have on their back 4,200 psi. 4,200 pounds per square inch. And CNG is very safe. Your neighbors in Athens, for example, the buses run on compressed natural gas. Your neighbors in Cairo have more than 100,000 vehicles running on compressed natural gas. Many places in Southeast Asia, if you have traveled that part of the world where they have the tuk-tuks, you know, and they used to emit a lot of fumes, etc., now they run on compressed natural gas. And with heavy traffic and accidents, you don't hear about concern about compressed natural gas being safety. Even in bad collisions, the tank is always maintains its integrity. This is a CNG in a box. It's stations fueling CNG cars. This is, for example, a UPS. They now use CNG on some of their trucks. Even sanitation vehicles using CNG. Many municipalities want to be environmentally responsible and reduce emissions, so they go to CNG. Even trains running on CNG. This is the world's first NGV tram, opened in Malaysia in 2012, runs on CNG. So buses running on CNG, I spoke about this. Ships running on CNG as a fuel. And that's the ship that we have designed and got approval for construction from the American Bureau of Shipping to build, and which I will spend some time. What I wanted to make sure is that everybody's comfortable with CNG. CNG has been around for more than 100 years. Every pipeline is a form of compressed natural gas. And even our proprietary technology, which is this tank, we call it the Cocel. Cocel is not an English word. It's a word that's made from coil and carousel. And this tank is built with a 6-inch pipe. And the pipe is about 6 millimeters in thickness, or 1/4 of an inch in thickness. Very rugged, produced by more than 150 mills around the world. Each of these tanks is very large. It holds something like 4 million standard cubic feet. It has 21 kilometers of pipe. And this is what has been approved for construction. And each ship has a number of these modular tanks. So the tank is the same tank, and the size of the ship is determined by how many of these tanks is on a ship. So for example, this is a C-25, it has 25 of these units. This is a little bit of specifications of the tank, the size, the weight. It weighs 620 tons, and then when you fill it with gas, you add another 50 tons. A very rugged system. And there are other CNG solutions that are built in bottles. The problem is the larger the bottle, the thicker the wall you need. And when you go to very thick walls, you need very specialized metal, only produced by so many, maybe 4 or 5 mills around the world. Our pipe is produced by many mills around the world, so it's easy, it's low cost. And in the event, and it's very, very remote, like 1 in a billion probability that there would be a rupture. In the event of that, it's like when you have a leak in your tire. It doesn't explode. The gas has to travel a long distance. The gas is choked. So it's a very safe and rugged solution that is there. As I mentioned, we have different sizes of ships. These are the number of Cocels on each of the ship. And you have the capacity and the volume, the breadth, depth, and the loaded draft, how much of the ship is underwater. And again, we optimize the choice of, for any project, it depends on the distance and the volume that needs to be transported, and hence the number of ships. And you can stage the project. You can start the project with 1 ship. You can add a second, third, fourth. So you don't have to spend all your money up front. You can stage the project as your demand grows and as your comfort level also increases. In terms of loading, this is a simple jetty, and the intent of this picture is you can see how simple the loading facility is. Like, you know, if you compare that with an LNG facility, you can see the simplicity in the solution. Again, if you go to a discharge facility, it's even simpler. It's much simpler, and it takes a very small, footprint, which a lot of sometimes you don't have the space in Israel. Sometimes you don't have the space, and that makes it a much simpler solution. This is a solution where the ships are offloading on a buoy. It could be any distance from shore, and the natural gas comes through a pipeline, and then it's delivered to the facility, the power plant or the petrochemical facility. There are a number of other applications for loading or offloading. This is the single anchor leg, loading and offloading. There is the submerged turret loading, which we have seen in the animation. Now I will go to safety. In order to have a ship approved for construction, you have to go through very, very rigorous approval. Approval for construction is different from approval in concept. It's more than 400 drawings that engineers in the American Bureau of Shipping or DNV would have to look at before they stamp every drawing and say this is approved and it's safe. Because if you don't have approval from the marine authorities, no port master will want the ship to enter their port. They will see it as a hazard. So this is, I'm not going to go over all these studies, but volumes and volumes and volumes of studies and testing that have gone through 14 years to get to the point where we have CNG available for marine transportation. And I want also to mention something is you need to go through this approval even though CNG is very simple. Like when you ask the engineers who know about LNG and about oil, the degree of complexity for CNG, if LNG on a scale to 1 to 10, if LNG is 10 in terms of complexity, CNG is 1 or 2. So it's really, because it's really a pipeline that is coiled. And then you have a bunch of valves and control systems that are available in the industry. Again, the coil pipe is simple, and because it's very large with minimum valves and connections, it's safe, and because of that, it's a lower cost, and this attributes to a good rugged solution. This is the approval from the American Bureau of Shipping. The testing of the tank went 65,000 cycles with no failure. I mean, and a cycle means a trip, like going to destination and coming back. In terms of real time, 65,000 cycles represents 1,000 years of our operations. Now, all the projects that we're looking at are anywhere between 5 and 25 years. But this is the kind of testing that you need. It's if you're building an aircraft, the wing would need to be tested to the same standard because you can't have wing fall off the plane in a flight or something like this. Because once the tank is built, it goes in the ship. It's not going to fail. So let's talk about the niche market, because as much as sometimes people say it's competition between CNG and LNG, I see it as complementary. It's a niche. If you have gas, you need to look at all solutions that are available in order to maximize your netback. Netback is the money that you keep in your pocket after what you get at the destination, less the cost that are involved to get the gas to market. So in this chart here, this is, I know you might not be able to see it, like this is the volume, and this is the distance. And before there was CNG, this would be the region, the most economic region under normal conditions for pipeline. And this was LNG. Under 500 million cubic foot, like LNG, it's not practical. It becomes too expensive. And so if you are a company like Noble or Dalek and you found gas, let's say here at this distance and this volume, it's nice that you found the gas, but it's stranded. It's too expensive to build a pipeline to shore, and it's not enough to build an LNG facility. The chart here on the right is what the CNG, the area that it opened, again, is. So what used to be considered stranded now can be developed. And that makes it very interesting because when you're looking for gas, you're lucky here in Israel that you found Tamar, 11 TCF, 10 or 11 TCF. Leviathan is 20 TCF. These kind of finds, that they're world class. You don't find that kind of volume every day. What you normally find is a half TCF, 1 TCF, 1.5 TCF. And these volumes, sometimes when you find the large volumes, it sounds like the small volumes is not big enough. But these small volumes can be developed and can produce a lot of value for the producers and a lot of value for the market. As I mentioned earlier, the economic distance of CNG is 2,500 kilometers. So you need to have a gas source and a market within that distance. And the green area represents, and also the light blue areas, the location in the world where there is the potential of using CNG. The green areas represents the areas in the world where we have active projects under development. And you can see that the whole Med is very interesting. You have a lot of gas in North Africa, and now in Israel, Lebanon is talking about gas, Cyprus, and even Greece looking for gas, and they have some minimal amounts. But you have proximity between the source of gas and the market. It's within that economic distance. And I'll tell you in a little bit why that is important. This is a map that shows the source of gas in Israel and the potential market that exists. And you have the distance, the circles of distance. So, within 2,000 kilometers, you can even reach Malta. You can reach Sicily, Italy. Many places in Italy that are already, even one place in Italy that we're working with, have converted a port to receive CNG. So this is a very important part for the producer, like why CNG, why you should be considering CNG. In LNG, large investments, billions of dollars. 60% of the investment goes into the LNG liquefaction facility, or we call it loading for the comparison purpose here. 30% into the regasification facility or the receiving facility, and only 10% in the shipping. Remember, I mentioned very big ships, very dense LNG. So the cost of transportation of LNG is lower than CNG. Versus CNG here, you have 75% of the cost is in transportation, is in the ships, and 20% in the loading, which is normally a compression plant, and only 5% in the receiving facility, which normally is a very small plant to control temperature and pressure. This is a slide I want to just to show you. This is very important for producers. Is the case is LNG, for example. These figures up here are figures from July of last year, and I took the figure of the average cost of natural gas delivered in Europe, July of last year, $11.6 per million BTU, and subtracted from it is the cost of, for example, like I'll start with CNG, the loading or liquefaction is $0.6 per million BTU, and the transportation is 2.6, and the receiving facility is 0.15. And this is for 300 million cubic foot, 1,000 kilometers. So the net that you get as a producer is $8.25. Versus if you did that, like if you made LNG here in Israel and wanted to sell it to Europe, the net backs are shrunk to $4.1 per million BTU. I mean, and again, I'm not debating whether it's 550 or 750 or 475. You need to look at the magnitude. Is in terms of regional opportunities, you can achieve higher net backs in CNG than LNG. Now, when we go to global, that's my next slide. So I took the average cost of natural gas in Japan last July was $17 per million BTU. All producers look for Japan and Southeast Asia where you have the highest price of natural gas, and that's where you want to reach. Now, Japan from the Eastern Med, CNG cannot reach that. Like this is outside of the 2,500 kilometer distance, but it is within the LNG, of course, range. LNG is global. But if you look at the netbacks are close. So what that tells us is that there's huge opportunity for Israel to export gas into the region. You have Cyprus looking for gas for 10 years until they get their own. You have Turkey, huge market looking for natural gas. You have Greece, you have Italy. Even Egypt used to be an exporter, now they're looking for gas. It's a tremendous opportunity to be able to build links and achieve higher netbacks and get the value for the natural gas that you have here. So in conclusion, I want to say that CNG is simple, safe, reliable, and flexible. It takes advantage of the lower cost of regional gas. You can afford, like the gas here, for example, the Israeli electricity company gets gas at $5.8 or $6 per million BTU. If you use that as a base for the market in the Eastern Med, it's good value after you add the transportation. Fast implementation, the first gas can be delivered by ships in 26 months. Our ships are going to be built in South Korea. They build these ships like they build the Kia cars. They commit, and our partner DK that manages the production of the ships, their last 68 ships were all delivered on time and plus or minus 1% from the budget. So you don't have the headaches of cost overruns. Flexibility to redeploy the assets. I mean, some of the discussion that we're having here is Turkey is a large market. Pipeline makes good sense, but the pipeline has to go through the economic zone, exclusive economic zone of Syria and Lebanon or of Cyprus. And until Cyprus, for example, resolves the issues with Turkey, there is a challenge of getting a pipeline to Turkey. You can always start with CNG. Export CNG, get early revenue, and then when the right time comes to build a pipeline, you move that fleet to somewhere else in the world. So there are no stranded assets. It's complementary to LNG. We're working with one of the multinational where they found that they have a satellite LNG facility and they need to collect the gas for this facility. Putting subsea pipelines is too expensive for the volume, and they don't want to have stranded assets, so CNG can deliver the gas to the LNG facility. Very small footprint for the loading and the unloading facility. And our alliance, we are $110 billion in assets. We provide the opportunity to invest 100% of the cost of the transportation project. And we only ask the clients to pay for a tariff. It's either so many dollars per million BTU or a chartered rate for the ships. And as long as there are credit-worthy parties on both sides, our alliance are very interested to work with the clients. So I hope that kind of gives you a rounded picture of what CNG is and its safety record and how valuable a transportation means it is for a country like Israel. Thank you.